Hi, welcome back. In step 6, we are going to compute accumulated local effects. Remember, in the introduction, we said that the accumulated local effects, which I refer to as L, help us to understand the nature and direction of marginal effects. The marginal effects shows us how a response variable, for example, length cover, changes when a specific predictor variable such as a spectral reflectance changes. So L is important because it helps us to infer the relationship between the predicted length cover and the spectral reflectance bands. Okay, so to learn more about L and the IML package that we are going to use in this tutorial, please check the links below. You can also check my book on data-centric explainable machine learning for length cover classification. Okay, so let us jump into the tutorial. So first, we will create a predictor object that is going to contain the machine learning model and the data. Please take note that the data contains the predictor variables from the Sentinel-2 bands and the response variable, which is the length cover class. Okay, so here we are just using the predictor new function in order to create our predictor RF object. Right? Please take note that for each observation of a specific predictor variable, such as band 2, L is going to calculate the average change in length cover within a local window. Okay, so let's run this chunk of code. Right, so to keep things simple, we are going to start by computing the L effects, and we also create an L plot for only band 2. So here we are going to specify our seed as we have done before, and then we are going to use the feature effect new function in order to create an effect for band 2. And then here we are just going to plot the effect, and then we are specifying band 2. So let's run this chunk of code. Right, here's our output that we get. Notice that here we have the different length cover classes: bare areas, built-up areas, cropland, grass open, water, and woodlands. Right, on the y-axis, we have our L values, and then on the x-axis, we have the band 2 spectral reflectance values. Right, the L plots are centered at 0, which represents the mean model prediction across all values of the bands. Values above 0 show a positive effect on the predicted length cover. That is, we have an increased length cover prediction. While values below 0, they show a negative effect on the length cover, which is a decrease in length cover prediction. Right. Let's try to interpret one point. For example, let's observe a point in the built-up class. So here, let's say this point is 0.8, So the L value is 0.8 and the spectral reflectance is around 0.1. So what does this graph shows? So it shows that for a spectral reflectance value of 0.1, the predicted probability of lane cover increases by almost 10% compared to the average prediction. Okay, so this is quite important information. So if we look at these plots, we only see that the built-up area is actually showing the positive effect. Okay, we have a very steep increase in prediction, which peaks at about 0.8 in L value at a spectral reflectance of 0.1. But as the spectral reflectance increases, we just see that it becomes the L values becomes flat. Okay, and when we look at the other lane cover classes, we just don't see much a change except for the bare areas where we have very little increase in the L values, but then it flattens to 0. Okay, and then for the cropland, there's just a steep decrease in the L values as the spectral reflectance increases. For grass, open areas, water, and woodlands, there's a little or no effect. Okay, we almost have flat lines. Right, so this shows that the model is performing poorly except for the built-up areas. So this is a big concern. Okay, so next we can also create the L plots for the other bands, band 3, band 4, band 5, and band 6. So to do that, first we'll just create an object that contains these bands, band 3, band 4, band 5, and band 6. And then we'll use the feature effects new to create this object, which I've called feature effect RF1. So here we're simply taking the bands that we have specified, bands 3, band 4, band 5, and 6. And then we run the chunk of code. This produces the L plots for band 3, for band 4, for band 5, for band 6. Or we can do the same for band 7, band 8, band 11, and band 12. So if we create an object which contains these bands, band 7, band 11, band 7, band 8, band 11, and band 12, we will get another plot showing these bands. So this is for band 7, band 8, band 11, band 12. Okay, I'm not going into details in explaining these plots. If you want to check out how these plots can be interpreted, please check my free ebook at the IGeoLabs website. I'm also going to leave the link below, and you can also check my new book also on data-centric machine learning for lane cover classification, which has got more explanations. Okay, so this is the end of Lab 1, Explainable Machine Learning using ML package. Okay, so please subscribe to my channel to get notifications of new tutorials. I'll be producing more tutorials, especially on the data-centric explainable machine learning. Right, so the next tutorial will be on Lab 2. So thank you very much. See you in the next tutorial.